Solving two-step equations. So when we solve two-step equations, we're going to think of a shoe and a sock. And in order to get to your toes, which in this case we're going to call the variable, you have to take off the shoe first before you can get to the sock. And then in order to get to the toes, you have to take the sock off. So it wouldn't work for you to take the sock off first while the shoe is on. So the same thing is going to apply to a two-step equation. We're going to undo the addition and subtraction first, and then we're going to undo the multiplication and division. So you almost want to think of it as reverse order of operations. So we're now going to start with the back of PEMDAS. Alright, let's look at our first example. So the first thing I want to do, I have 2x plus 3 is equal to 9. I want to draw my line through the equal sign to separate both sides. Remember, I think of a scale. I want to balance that out. Okay? And now I want to highlight my variable because my variable is the last thing that I want to get by itself. So in order to do that, I have to think of the shoe and sock method. I'm going to take away the 3 first. So I'm going to subtract 3 from both sides. And when I do that, the 3's are going to cancel out, and that's going to give me a 2w is equal to 6. Okay? Now again, I need to do the inverse operation. So if I have 2w, you want to think of what operation is 2w. Hopefully you said it was multiplication. So the inverse operation of multiplication would be what? Correct, division. So I'm going to divide both sides by 2. And when I do that, I have my 2's are going to cancel out, and then I'm left with a w is equal to 3. Now what I really love about solving two-step equations, or anytime you solve an equation, is it's so easy to check to see if you have the right answer. So now we're going to plug back our variable into the problem to check to make sure that we got the problem correct. So I'm going to have 2 times 3 plus 3 is equal to 9. Okay? 2 times 3, that's going to give me 6. And then I'm going to copy down the rest. Plus 3 is equal to 9. 6 plus 3 is going to give me 9. So that gives me 9 is equal to 9. So it checks out. Alright, let's take a look at a second example. 3p minus 10 is equal to 8. So again, the first thing I want to do is I want to draw my line through the equal sign. Okay, I want to identify the next step. So my next step, what do you think that's going to be? You're right. I want to highlight the variable. So when I highlight the variable, that means I'm going to keep that alone. I want to keep that by itself because it's the last thing I want to get to. Okay, so now I have to get rid of the subtracting 10. So I want to think of the opposite of subtracting 10 is adding 10. So I'm going to add 10 to both sides. When I do that, my 10's are going to cancel out, and that's going to give me a 3p on the left side, and then on the right side, I'm going to have 18. Okay, so now I have 3p is equal to 18. How am I going to get the p by itself? Divide by 3. Use the inverse operation. So now when I divide by 3, my 3's cancel out, and I'm left with p is equal to 18 divided by 3 is going to give me 6. Okay, so I think that's my answer, but let's just check to make sure. Let's plug it back into our original problem of 3 times 6 minus 10 is equal to 8. Okay, order of operations, 3 times 6, well that's going to give me 18. 18 minus 10 is going to give me 8. So 8 equals 8. Alright, let's take a look at this next one. Now one suggestion that I may have for you is that you might want to try and pause the video right now and work on this problem on your own. Alright, so I want to draw my line through the equal sign. And then I'm going to highlight my variable, which is the d, and everything that goes with it. So because the 4 is with it, I'm highlighting that. Okay, now I want to do the inverse operation of subtracting 9. So basically I want to find a way to get negative 9 to 0. In order to do that, I need to add 9 to both sides. Okay, so when I do that, my 9s are going to cancel out, and I'm left with d divided by 4 is equal to 12. Okay, now the opposite or inverse operation of division is multiplication. So I'm going to multiply both sides by 4. And when I do that, it's really 4 over 1, and my 4's are going to cross simplify down to 1's. And I'm going to be left with d is equal to 12 times 4, which is going to be 48. Let's plug that in for our check. So I have 48, because that's my d value, divided by 4 minus 9 is equal to 3. Okay? So when I do 48 divided by 4, well, that's going to give me 12 minus 9 is equal to 3. And then 12 minus 9 is 3. So 3 is equal to 3. That check works out. So that means d is equal to 48. Alright, let's take a look at this next problem. Now I've made this problem a little bit different than the other ones that we've been looking at and kind of what we've been talking about. Okay, so I have 3 plus x's in parentheses, but then it's divided by 5. So I want to make sure that I separate my two sides out. But remember, we talked about the shoe and the sock method. Okay, in order for me to get to the toes, I can't just take off the sock with the shoe on. Okay, I have my variable, so I have to highlight what's with my variable. And we talked about the reverse order of operations. So in this case, I have 3 plus x is together because it's in parentheses. So that's the last thing that we want to make sure that we take care of. So in order to do that, I need to get rid of that divide by 5. So the opposite of dividing by 5 would mean I'm going to multiply by 5, both sides. Okay? So in this process, while I do that, my 5's are going to cancel out, and I'm left with 10 times 5, which is going to give me 50. So I have my 3 plus x is equal to 50. Now I can get my x by itself. In order to do that, the opposite of 3 would be a negative 3. So I'm going to add a negative 3 to both sides. The 3's are going to cancel out. And that's going to leave me with x is equal to 50 minus 3 is going to give me 47. Let's take a look at one more example. If I have negative 3y plus 2 is equal to 26. Now the negative 3y, negative number really has no effect on this problem. We're just going to solve it the exact same way that we always would. So we're going to draw our line down the middle. Let's highlight our variable. Okay, so the negative 3 has to go with the y. I can't just ignore the negative sign. Okay, I have plus 2, so I want to figure out what's the opposite of adding 2, so I need to subtract 2. So in order for me to do that, I subtract 2 from both sides. My 2's are going to cancel out, and I'm going to be left with a negative 3y is going to be equal to 24. Now, how would I get the y by itself? You say to divide by negative 3. That would be correct. And you divide by a negative 3. And my negative 3's are going to cancel out, leaving me with a y is equal to, now if I have a positive divided by a negative, my answer is going to be negative, and it's going to be a negative 8. So that would be your correct answer. Alright, so I have 4 more examples here. Here's what I would like for you to do. I'd like for you to pause the video and solve these 4 problems here. And when you're done, press play, and then as you go on, you can check your answer to make sure that you're getting the correct answer. I will have the steps laid out for you on how to solve it. At this time, I would like for you to write down the Minnesota Wild win Game 7 in your upper right-hand corner of your notes page. Don't be afraid to bob your head right now. And welcome back. So here's how you solve. Here's the answers. If you have any questions, please feel free to go back and watch the video at any point in time and fast forward to parts of the video that you might need to see and have those worked out.